In part 2 of weeks 5 to 6, we will focus on the segments formed when chords, secants, and tangents of a circle intersect. So these are the concepts, but just like one of our previous videos, we are not going to read these concepts anymore, but rather we will refer to these concepts. We go back to these concepts while we are solving for the examples. So we will be properly guided on what to do and how to go about our calculations. But we have three concepts right here. We have the intersecting chords theorem, the intersecting secants theorem, and the intersecting secants and tangents theorem. So let us go to our examples. So we have to find x in the figure right here. Obviously, we have two intersecting chords. So we will refer to our first concept, the intersecting chords theorem. So if two chords of a circle intersect, then the product of the segments of one chord is equal to the product of the segments of the other chord. So what are these segments of chords? So let's go back to our figure. Let's name our chords. Say for instance, this is chord AB here, and this is chord CD with our point of intersection E. The two chords AB and CD intersected at point E, which divides each of the chords into segments. So chord AB was divided into two segments, AE and BE. So let's use a different pen color for this. This is segment AE and segment BE. These are the segments of chord AB. Also, segment CD was divided into two chords, segment CE and segment DE. So these two segments are the segments of chord CD. Now, according to the concept, the product of the measures of the segments of one chord is equal to the product of the measures of the segments of the other chord. Hence, we have here segment AE times segment BE is equal to segment CE times segment DE. So after forming this equation, which happens to be the concept, the intersecting chords theorem in equation form, let us substitute the values, plug in the values from the figure. So this is 15 times BE, which is 4, is equal to CE, that is 5, and DE is X. So let us multiply. This is 60 is equal to 5x. Since we are solving for x, we want to divide both sides by 5. So we can cancel 5. And we are left with x, which is 60 divided by 5. That's 12. And that is our final answer. Let's move on to our second example. So we have here two intersecting secants. So let us refer to the intersecting secants theorem. So if two secants are drawn to a circle from an exterior point, then the product again. So we are going to multiply, but what are we going to multiply to each other? The measures of 1 secant segment. This is the whole thing, the whole secant segment, and its external secant segment is equal to the product of the measures of the other secant segment and its external secant segment. So we have here a certain figure that we are unfamiliar with, which is the external secant segment. If we are going to refer to our figure right here, segment SI is our secant segment. But since segment SI is drawn to a circle from an exterior point, some parts of our secant segment is outside the circle. Say for instance, segment HI here. Yusin ko lang ha. Segment HI. That is the external secant segment. So, in the case of our other secant segment, that is segment TI, the external secant segment is segment FI. So according to the concept, the product of 1 secant segment, so segment SI, and its external secant segment HI is equal to the product of the other secant segment TI and its external secant segment FI. So again, just like in our first example, after forming this equation, which is just representative of the concept, what we want to do is to substitute the values. So SI here is 16 and HI is X. That will be equal to TI, that is 18. Why 18? Because segment TF is 10, segment FI here is 8. So therefore, the whole thing, segment TI is 18 times 8. So what we want to do next is to multiply everything. So we have here 16x is equal to 18 times 8, I think is 144. But I'm not so sure. So let us use our calculator. 18 times 8. That's 144. Since we are solving for x, what we want to do is to divide both sides by 16. So we can cancel 16 and we are left with x, which is 144 over 16. 144 divided by 16. That is 9. So our final answer is 9. Last example. So we have here a secant segment and a tangent segment. So let us refer to our theorem. So if a tangent segment and a secant segment are drawn to a circle from an exterior point, then the square of the tangent segment is equal to the product of the secant segment and its external secant segment. Notice that in our second example, so we are multiplying the secant segment by its own external secant segment. Hindi pwedeng magkapalit ng partner. However, in our third example, the tangent segment, wala siyang partner. So, we are going to multiply it to itself. So, square the tangent segment. And in this particular case, the tangent segment is segment EV. So, we square that. That is equal to the product of the measures of the secant segment, segment LV, and its external secant segment OV. We now then substitute the values. So we have here EV, that is 10. 10 squared is equal to LV, the whole thing is 25, times OV, that's X. So 10 squared, that is 100, is equal to 25X. So divide both sides by 25 since we are solving for X. So we can cancel 25. We are now left with X, which is equal to 100 over 25. That's 4. And this is our final answer.